Hello, my name is Artur and today I will be showing you how to assemble this. This is a monocopter. If you want to know what it flies like, see my previous video which shows a flight of version 17.3. This is actually version 17.4. It has a slightly bigger wing. And I printed this on my own 3D printer, which I got recently. It's a Creality Ender 3 S1. My previous versions were all printed on an Ultimaker 3, which I used on my university. So you can see my printer still isn't tuned perfectly, but I'll see how it flies. The main difference is the bigger wing. Yeah. So, through the magic of having pre-recorded the assembly, let's get on into the assembly. So as you see, these are the parts that we'll need, as well as some tools, such as cyanoacrylate glue, a file, or alternatively you can use sandpaper, preferably some tissues, some cutters, some sort of knife, some smaller file would be good to have, and preferably gloves, because we'll be dealing with cyanoacrylate glue, which is quite annoying. We will also need a soldering iron. So this wing is a bit bigger than in 17.3. But it is lighter, so maybe it will work better. That's something to test out. And to make it lighter as well as bigger, I had to drastically reduce the amount of infill. So this one uses gyroid infill, and you can see the lines here, but it's not very smooth. I don't know if you can see it. It's not very smooth, which is probably due to it not cooling evenly, but also probably due to the low amount of infill. So this is actually 17.2. It is much smoother. As you can see, it was printed on the Ultimaker 3, but here you can see the infill is much more dense. So I think this was printed using 1% infill, whereas this was printed using, I think, 0.8% or something even lower. And as you can see, this design, it broke here because it was quite thin. I fixed this in 17.3 and even more so in 17.4, which not only has it thicker, but this part actually has two layers, two outer layers instead of one. The rest is just one layer. Yes, so the main upgrade here is a bigger wing compared to the one you saw in my most recent video. So let's get on to assembling this thing. Firstly, you will want to remove any sharp corners from these 3D printed pieces so that they fit better together. And for this, you can either use a knife or you can use a small file such as this. So I'll just go around here. This should be fine. And then the other pieces as well. can use the upper edge so that you don't remove too much material, just get rid of the remnants from the filing. And this piece, it's quite important in this piece to have it even so that it fits well on this one, but I think this one is mostly fine. We can give it a little file. Okay, so now you can see that there are some holes here which are intended for reinforcement of these two parts using this wooden barbecue skewer. The one I use are about 2.7 millimeters in diameter. I just found those at my local shop. So you will want to cut some pieces about 1 centimeter long, slightly less. You need 2 of them and one longer one, because the longer one will actually pass through this part and it will go a bit into this one. It will actually be part of the mechanism for fitting this part in place. So let's cut a bit here and see how well it fits. It is a bit too long. I'll cut it a bit shorter. This should be fine. Yes. So now we need another one like this. And there will also be one here, which will be slightly shorter. Okay, I think this will do for this part. And for here we want one that is a bit longer, so I'll just cut off a piece and measure how long it needs to be. There's some PLA stuck in this hole, so I'll need to clear it out, like so. Okay, so we know that it needs to be a bit longer to stick out, so let's just cut it here. And for this piece and the shorter one that will go in here, we want them to be nice and pointed so that they fit very easily into this part. For this we can use a file and just make it slightly pointy. Yeah, that fits quite well. We can also slightly enlarge this hole here using a knife. And now it fits even better. So now for this part, we'll do the same thing. Okay, so now onto the gluing. I'll put on the gloves so that I don't get my hands sticky, because cyanoacrylate glue is very annoying if it gets onto your skin. This is where the tissues come in handy. So now put some glue into, let's start with this part. Put some glue into these holes, just a tiny bit. And now put these into the holes. These squares are mainly to help with the alignment of the two parts, because the main strength will be in this gluing connection. So now we'll put glue on this face, not on this face, because this is supposed to move, just on this face. Go around the edges. And put some on those wooden sticks. Not too much. And slide the parts together. And press them hard against each other, but be careful not to break them. So just push them gently together for about a minute. It would have probably been better to do it the other way around, putting glue on this part, because I just realized there is some glue which is unused on these faces. But I'll also put some glue in the very small gap between the two parts, just to make it stronger. And now let's install this final piece. I'll just put a small drip of glue into this hole. And put it in. So now this part will fit nicely onto this part, and we can use a rubber band to fix the parts together. You would maybe want this to this stick to stick out a little longer, probably like in this part. I cut it a bit too short here, but it still works. So another thing you will want to do is, in order to install the motor, it's best to file down this bit because it's quite rough. So let's just take a file and go over it. This should be fine. Now let's see whether the holes are big enough for the screws. Yeah, they fit. So now we will put the screws into these conduits, like so. And we can install the motor. The motor is standard Emax NT1806 2280 kV. I've used it for a lot of my monocopter versions. So firstly you would want to push the wires through this hole. And they should come out on the other side. So now we can screw the motor in place. Make sure it's nice and tight because the PLA is slightly compressible. And also make sure the screws you are using are not too long so that they don't go into the copper windings in the motor. So we have the motor done. Now we can install the servo. For the servo I am using this Savox servo, which is quite fast. It runs on 6 volts and it has metal gears. So for the servo I've made these holes, which are for some M2 nuts. The M2 nuts go into the holes. We'll take a push rod. I have already made this push rod for my previous monocopter versions. And you need to push it through one of the holes here. I use the top hole normally. And through the servo horn. If the nut rotates, it shouldn't, but on this printer I have the tolerances a bit different. If it rotates, you can hold it down using something else. Okay, so the servo is in place. It can easily change the angle of the flap. This is the control board. It has an Arduino Nano soldered into it. And it's just a convenient way to have all the components for the monocopter. The magnetometer is here. It's farther away from everything else so that it doesn't get noise from the other components. And this is just a standard RC receiver which plugs in, and there's a buzzer if I ever need it for buzzing when, for example, the battery voltage is too low. So now you will want to solder the 3 wires of the motor to your speed controller. I'm just using a normal 12 amp speed controller with the battery connector soldered here. This is the control PWM connector, and I have another set of wires connected to the battery voltage, which will plug in to the board. Normally almost everything on the board is powered from 5-volt regulators on here, and also the one on the Arduino. The Arduino's 3.3 volt regulator powers the magnetometer, but because I want to achieve the highest possible speed on the servo, which is rated for 6 volts, I have a dedicated regulator which produces 6 volts from battery voltage, which is I am using a 2-cell LiPo, so it's about 7.4 volts. And the battery voltage powers a 6-volt regulator, as well as a potential divider for measuring battery voltage by the Arduino. I also have 2 medium power transistors for switching on high power LEDs, which I use on the tip of the wing in this slot here. So I'll just quickly solder this in. So now that this is soldered, I will put some electrical tape around my ESC. I removed the original heat shrink around my ESC to remove the original wires and also to make it more lightweight, because with the 3D printed wing it is a bit heavier than my regular monocopter. So now I'll put in the electronics. This wire connects to this port. Actually no, it connects here. The servo connects to the first port. That has 3 leads, because the power from the battery voltage it goes into the first port, which has only two pins. And this is where the battery goes. If you have a different sized battery, you can modify the 3D file. And I still haven't put in the lights, but for this version I won't put in the lights. This is just to test the new size of the wing. I might put the lights in later if it works well. I will install the propeller now. Oh, it's very important to use a propeller with at least 3 blades in a monocopter, because if you have just 2 blades, the propeller can break during flight, so just one of its blades will fly off. It's quite dangerous for both you and the monocopter, and it happens because of the varying moments of inertia as the propeller spins and as the monocopter rotates. I've read an engineering paper about monocopters which mentioned that they also had problems with 2-bladed propellers. So now, provided that you have the software on the monocopter, you can turn on the transmitter, make sure throttle is in the lowest position, plug in the battery, and the lid goes on top. You fix the part using a rubber band. Yeah, ideally you'd want the barbecue square to be a bit longer. Here I have it a bit too short, but... So hopefully this video was informative in some way. Thank you for watching, if you have watched all the way until the end. Yes, I made some mistakes in assembling this monocopter, but hopefully you will now know what mistakes not to make. So like, put a tissue on your table before you start opening super glue, because it will spill on the table and it is difficult to remove. So please don't do that. And yeah, I'll see how this flies, and hopefully it will be better than 17.3.